half of 60. Nothing but 30 meters. Now what you have to do?
Bhavana, Kavya.
Good afternoon, all the students. Yesterday we are not concluded our whatever the IIT advanced questions and page number whatever the 84 it will be there. Now, once taking all the students, last we are completed the fourth question now. Now we are doing the fifth question. Choose the correct answers. Multiple answers are there here. Once taking what they given. Newton's first law of motion is also called Galileo's laws of inertia. Okay, now that our whatever the Newton's first law is there, it will contain another name that is the law of inertia. Okay, yes, why it is called law of inertia? It will give the information about the inertia. Okay, it will give the information about the inertia. What is inertia? Why the body is not getting into the motion? That property is only given by the inertia. The tendency of the body motion is given by the inertia.
Time 3:20 it will complete.
Yeah, it is only called what? Inertia. Our first law is also gives about that. Unless until the force is acting on the body not changes its state. When we apply the force on the body changes its state. Unless until the force is not applied, the body not changes the states. Nothing but it contains inertia as infinity of the force applied on it. Okay, when we apply inertia may changes. Okay, that will be right answer only. The fifth one, A answer is the right only. And next, there is a B answer. But taking multi answers type purpose, you have to should check all answers. The answer B. Inertia of a body may be defined as the tendency of a body to oppose any change in states of rest or uniform motion. You know very well, the body is under uniform motion or rest, it's continuous in the same situation only till the force is applied on it. That property is only called what? Inertia. It is not ready to change its original position. That is only called what? Inertia. Okay. And that is why the answer B is also correct only. Got it or not? Answer B is also correct only. The next one, it is what we are considered. Yes, B. The quantity of sorry. Uh, One second, other students, there is a third option C. There is a what we are considered force is directly proportional to the mass, and the force is when the force is increases, there is a when the mass more we require. Okay, suppose you have to take any of the 2 kgs body and a 5 kgs body, they may given for you. Okay, at that time, which time there is a we are using the more force, which time you require a more force application. Yeah, when we are applied, there is a more force 5 kgs time. Why? Because the more mass is there, more force is to get the motion. Okay, clear or not? But acceleration is a decrease. Already we are discussing. One of your friend may add it to your bike. Another friend may add it to your bike. Another friend may add it to your. Automatically, the bike acceleration is a decreases. Okay, that's why the mass is increases. The acceleration is decreases. Okay, now in this way, there is a C is the correct only. Yes, in case the quantity given acceleration, it is inversely proportional. The quantity, whatever for a motion, it will be given as a force. It is the directly proportional. Next one is a D. The tendency of the body opposes any change in its direction of a motion by itself, known as the inertia of rest. Yeah, it is not called inertia of rest. The direction change in the tendency is there. It's a called inertia of direction. Okay, now there is a 3 types of inertias are there. One is the inertia of rest, that is also called static inertia. Another one is we called as the inertia of direction. Another one is inertia of motion, that is a kinetic. Direct kinetic inertia, static inertia, direction of inertia. Direction of inertia nothing but it is not ready to change its direction. That is why only circular motion may get. Everybody want to move in a which motion? Linear motion only. But it is not ready to linear motion when the force is applied at a center. Okay, clear or not? That is why the body selected not a linear motion, not coming toward the center. It will be selected circular path. You know very well. Got it or not? Yeah, this already we are discussing. Okay, that is why the third answer is wrong. A, B, C are correct statements only. Okay, clear or not? Yes, one check it. All the statements are three correct only. Next, sixth one. What is the sixth one they given? Unable to change, inertia is the property of the body by virtue of it, which the body is. Okay, when we get the inertia, the question is when we get the inertia, when the inertia is available. The answer they given unable to change by itself at the state of rest. Yeah, when it will be want to change its state of rest, the inertia is working. As unable to change by itself state of uniform motion, yeah, then it will be already contain 5 meters per second. It is not ready to change it is into 10 meters per second. Okay, now yes, that is also called inertia of motion. Next, unable to change by itself, it's a direction of motion. Unable to change, okay, now by itself, it's a direction of motion. Yeah, when we want to change the direction of motion, the body is not ready to change. Okay, clear or not? These three types, there is inertia is working. There is a D option is a given as able to change by itself the direction of motion. No, not ready. The body is not ready. Able itself it is by the direction of motion. We have to should apply somewhat force. Otherwise, it is may not change its direction. Got it or not? That is why the answers are what? Sixth answer also A, B, C only. Okay, got it or not? The sixth answer is also A, B, and other C. Correct answers are this. Seventh question. Yeah, in the seventh question, there is a math of following. It is there. 4 problems are there. Numerical problems are there. I'll give the one problem for you. Okay, now remaining you have to do. Okay, clear or not? How to solve the problems? You have to should know. Every problem only. I am myself only. I'm given the explanation for every problem. Till now, you are not done any problem by you. Okay, just there is a seventh problem. There is a 4 similar things are there. Okay, now you have to calculate what is the impulse, magnitude of impulse of the net force. Okay, the question is given in each situation. 1000 kgs of car is moving along a straight line in a east-west road. Then match the magnitude of the impulse of the net force. So many are may find out the net force. Okay, but may not find the impulse. There is a impulse is required. What is the formula of impulse? The impulse is equal to, okay, the impulse is only the change of momentum. That is equal to force into time. Okay, it is only called what? Force into time. Got it or not? Here, there is we have to find out impulse. What we require? Force. The net force is applied on the body is required. And the next the time is given in every situation. What they given? Yeah, this is the east direction. The car is started here. The car contain how much mass? It is a contain 1000 kgs of mass and it is traveling towards the east with a somewhat 25 meters per second. Okay, na velocity, and it is a comes at rest after 10 seconds, after 5 seconds. Then what is the impulse of the car? Okay, now this is the problem. First, we have to take a problem number A. Okay, now what they given? Initial velocity they given 25 meters per second. Towards where? Towards the east. Got it or not? And here, how much time it's a travel? Okay, now yes, sorry, it is a comment the rest to stop in 10 seconds. The force is applied up to the 10 seconds. Okay, clear or not? And the final velocity become 0. Okay, now mass is given how much? 1000 kgs. Now we have to find out impulse. We not have acceleration. We not have force directly. First we have to find out acceleration. Then next you have to find out the force applied on the body. Then next you have to find out impulse. These are the works you have to do. And you know very well what is the acceleration formula? V minus U by T. Here it is the moving along the positive x-axis direction, but there is a magnitude become minus. There is no problem. Here A is equal to taken as 0 minus what is that? 25 meters per second. How much time it will become? This is only the acceleration minus 2.5 meters per second square. Okay, clear or not? Why? Because the final velocity becomes 0. It is a retardation. Okay, not acceleration. It is a retardation. Okay, now there is acceleration make it for us. Now, what is the mass is applied on it? What is the force is applied on it? F is equal to m into a. What is the m here? 1000, and it will become what? 2.5. The retardation or maybe acceleration. The force is applied on it, and now how much it is? 2.5. That is a 0. Okay, 2500 newtons is the force is applied. Got it or not? Now impulse is equal to how much? The impulse is equal to taken as yes, is F into T. Okay, now what is the T here? 2500 into 10. That is become 25,000 Newton seconds. Written or not it is? Yes. And answer is become what? For answer A, A is become R. A match with the what? R. Like that only you take for a B. Okay, S which may get 20,000. Yes, got it or not? One check it. In the B, what is the changes are there? In the B, there is a what is the changes are there? In the B, there is the place of U, there is a given 25 meters per second only, and angle of C is equal to only value, that is the 5 seconds. Got it or not? V is equal to become what here? 0 only. And M is equal to also become what? 1000 kgs only. Now A is equal to become what now? V minus U by T. That is the 25. 0 minus 25 by 5. It will become what now? It will become minus 5 meters per second. Then F is equal to become what? 1000 into acceleration is the 5. That is become 5000 newtons. Got it or not? Now impulse is equal to become what? The impulse is equal to taken as yes. What it is? It is equal to as what the mass? Sorry, F into T. That is the 5000 into what we have the time 5. That is automatically 25,000 Newton second only. Again, it is also 25,000 Newton seconds only. Okay, clear or not? Impulse is not varied here in this particular situation also. The seventh B answer is also become what? Yes, R only. B is also matched with the R only. Okay. Yeah. Please note down. Yeah. There is a C. Again, you have to find out the forces, and then we are get it is a 20,000 only. And next there is a D. When you take a D, a car is initially moving the east at a 25 meters per second, and over a 30 seconds period of the period, the car again reverse direction. Yes, the final velocity and initial velocity both are 25 meters per second only. Okay, now then what it becomes? It will be moving with a uniform velocity. When it's the body is moving with a uniform velocity, the acceleration is become zero. There is a no force is applied on the body. There is a no force, there is a no impulse. Then answer is become zero. Okay, now there is the answer is matched with the what? Yes. S is given as 0. The D is matched with the yes. And there is the next C is matched with the yes. C is matched with Q. Okay. Yes. Once do it. One more important problem here. The conversion of the units of a force from one unit system to the another unit system. Yeah, what they given here? They given as the nth question 10x dyne is equal to 10 newtons. Okay, clear or not all the students? 10, not 0, it is just 10 to the power of. That is one. Yes, and 10 newtons is equal to how many dynes? Okay, the newtons is written as newtons is the units of force. The newton is written as S is equal to what? 1 kg into meter, 1 meter by second square. Got it or not? This is the meter actually. Then dyne is written as what? Dyne is CGS system. CGS unit of force. It is a what? CGS unit of force. Yeah, there it is written as dyne is equal to what here? Dyne is equal to written as 1 gram into, okay, clear or not all the students? 1 gram into 1 centimeter by second square. Okay, it is a kg meter per second square. It is a S gram centimeter per second square. Got it or not? Yeah, you know very well. 1 gram is equal to how many kgs? Okay, clear or not all the students? 1 gram is equal to how many kgs? And as well as 1 centimeter is equal to how many meters? Got it or not? You have to take it here now. 1 gram is equal to how many kgs? 10 to the power of minus 3 kgs. 1 meter is 1 centimeter is equal to how many meters? 10 to the power of minus 2 meters. Got it or not? Now you have to substitute in the place of, okay, now what they given? 10 times and 10 newton. Here x is at where? Here. Okay, x value at where? At this particular position. What is the power may get for x? Okay, now it is also written as, okay, now 1 gram is equal to how many kgs? 1 gram is equal to how many kgs? 10 to the power of 1 kg is equal to how many grams? 1 kg is equal to how many grams? That is opposite to this. There is a 10,000 grams. Okay, now, and as well as 1 meter is equal to how many? Yes, 100 centimeters. You substitute in the place of dyne. Okay, now in the place of dyne, you have to substitute in the place of grams, in the place of centimeters, or otherwise in the place of 1 kg is equal to how many dynes? How many grams? There is a 1000 grams. In the place of newton, okay, 10 newtons is equal to 10 into. Yes, in the place of newtons, you have to write in the form of grams. Okay, clear or not? What you have to write? In the place of newtons, you have to write it is in the grams. Okay, here we have to write 1 newton is equal to how much? May we consider both. Okay, now, yes, for this purpose I am drawing here as 1 newton is equal to 1 kg as a kg meter by second square. Then 1 kg is equal to how many grams? 1000 grams we are considered. 1 meter is equal to 100 centimeters we are considered. The two values are substitute here. As 1 newton is equal to as 1000 into. Got it or not? Yes, 1000 what it is? Grams into how many meters? 100 centimeters. 1 centimeter is equal to 100 centimeters. Seconds same here. Yes. Now you check it here. What the prefix value get? 1000 into 100 by 1 as gram. Okay, centimeter per second square. Written or not it is? Written or not it is? Yeah. Now 1 Newton is equal to 10 to the power of 5 gram centimeter per second square. 1 gram centimeter per second square is equal to become what? Dyne or not? Yeah, there is a 1 Newton is equal to 10 to the power of 5 times. Okay, clear or not? 10 to the power of 5 times. Then the given what? 10 newtons is equal to what? 10 into 10 to the power of, okay, 9 is here consider. 10 cancel. Then it is x is equal to what we have? X is equal to we have 5. Got it or not? In a formula, what is the problem? X. 10 to the power of 5 times is equal to 10 newtons or not? Okay, that is only we have to write here. Just the conversion only. Okay, in case there is a for how many dynes there is a dynes is a convert into newtons in this way. Newtons is a convert into dynes 10 to the power of -5. Okay, clear or not? Newtons is a convert into dyne 10 to the power of -5 when we add it. Okay, like that we are considering. Got it? Yeah. Please note down. This is the formula. Yes, we are used regularly. 1 Newton is equal to 10 to the power of 5 dynes. Yeah. Next we have in a lecture. There is a whatever next lecture we have a lot of information. Yes, about the force applications. Already you have the same concepts in your regular syllabus also. There is a different types of forces are there. Okay, the contact forces and as well as the non-contact forces are there. But especially in this particular lecture, we are not go depth in depth. There is only the concentration on tensile forces mainly. Why? Because the tensile forces are general life. We are applied so many where. Okay, especially in a crane system, especially in a lift system. Means what? Whatever the lift is contained in a buildings, that is also working based on that system only. And at cranes, there is nowadays there is all the bridges and all the constructions are mainly working based on the crane application only. Yes, and there is the tensile forces and mainly contact force. It is the one of the contact force, tensile force. Yes, based on that one only, these all the machineries are working. The next lecture we are going to discuss about that. Before going to that, what is the force? And because of the force, what the applications are making for us? Yeah, you know very well the force definition. It is not called as a pull or push. Pull or push is an actions of forces only. Got it or not? It is just the action of force. It is a not of force. We are applied a force that pull or push may occur. Okay, or otherwise the force is either in the form of a pull or a push. That's it. Got it or not? But it is only not a pull and a push. Already so many times I repeat this definition. Force is one of the physical quantity which changes shape of the body, or direction of the body, or state of the body. State is nothing but rest to the motion, or motion to the rest. Shape is nothing but as any of the shape, circular to the another shape, or the rectangular to the another shape, or direction. It will be moving in a form of a straight line. Then after again it will be changes. It's a straight line from a straight line to the any circular motion or any curved path like that. Okay, this quantity is only called what? The forces. This force is also give how much applied force is required to motion and how much force is applied to stop it. These all the things are available in this. Got it or not? And these forces are so many types: internal forces, external forces. Okay, now force is the contact, force is the non-contact. Like that, so many types of forces are there. Somewhat pseudo forces are there. Okay, now suppose there is example is some forces are may not working on the particular initial, but suddenly there is a because of the motion of the body, nature of the motion of the body, the forces are generated inside of the body only. Example is the cyclones. Yes, our archaeology, whatever archaeologists are there, they're given the whatever the broadcasting of the weather they given, but that may not true every time. Okay, the cyclone may get in a Visakhapatnam, but they not get it as Visakhapatnam. May it will be moves to the Chennai. The problem is not estimation of that person. The problem is pseudo forces of Earth. Okay, because of Earth rotation, there is some Coriolis forces are generated. Because of the Coriolis forces, the whatever the air direction is there, it will be changes. Like that, so many forces are there. About that forces and application of forces, we are going to discuss tomorrow. Okay, yes, and especially we are going to discuss in the next lecture about the contact forces only. Okay, now, yes, thank you, Vananda.